Now that we've learnt about loops, it's an excellent opportunity for us to learn about arrays, because arrays and loops often go hand in hand. So, what is an array? Well, an array is a variable. That's the first thing you need to know. It's a special type of variable. It's a variable that represents a collection of identical objects. In other words, it might be a collection of integers, or it might be a collection of floats, or a collection of chars. We think of an array of characters, or an array of integers. There can be as few as one element of the array. You can have an array of one integer if you want to, which is a little bit silly because you could just declare an integer instead, but it is possible. How big can an array be? Well, that depends on the memory architecture of your system, but theoretically as much as memory will allow. In other words, you could have 100,000 elements of your array. You could have 100 million elements of your array. It just depends on your computer. So, is this an entirely new concept, or have we already seen arrays before? Well, we have kind of had a brief look at an array before. We saw an example of a string. Now, remember, if you will, that strings were arrays of characters. That's not all a string was, though. A string was an array of characters that was terminated by a null character. It's important to remember that. If it wasn't for this null terminating character, then a string would simply be an array of characters, and that's all. Just a bunch of characters, a collection of characters. And it's the null terminating character that turns it into a string for us, a piece of text, something that can be printed and copied and so forth. Recall from our discussion on strings that this is how an array is declared, or this is how a string was declared, and I'm going to now extend that to the general case and show you how arrays are declared. Firstly, you have a type name, in other words an integer like int or char or float or double, one of the basic types. It can also be long or unsigned, any of those. Then you have the array name. This is like the string name. This could be anything. This is a name that you invent. This is like my collection, or bunch of apples, or whatever you want to call it, list of boys' names, anything that makes sense to you. Finally, you have square brackets that surround an integer, a whole number. You cannot put the name of a variable inside the square brackets when you are declaring an array. You can do it when you're referencing an array, when you're using one, but you can't do it when you're declaring one. This is the reason for that. The compiler must know at the time that the program is being compiled how much memory will be set aside for that array when the program is run. So in other words, it has to be a constant. You can put something like 6 plus 7, as long as it is 6 and not a variable that contains a 6. But if you put 6 plus 7, the compiler can figure that out. It goes, okay, well that's really 13. It's got to be something that the compiler can figure out at compile time. It cannot be anything that could be determined at runtime. That's why it's a literal, or something that evaluates to a literal. Okay. Once an array has been declared, you can reference each element separately. For example, if we had an array of floats, in the previous declaration example, the type name might be float, an array name might be float array, and the int literal might be, I don't know, 20, some large number of floats. So then, if we ever needed to assign one of those elements, we could do it like this. Float array square brackets 5 equals 3.56. In other words, we're taking the float value of 3.56 and we're assigning it to the sixth element of the array, to the sixth element. You think, hang on, no, that's wrong. It's got to be the fifth element, right? No, it's actually the sixth element. So why is it the number 5 mean it's the sixth element? Well, I think I referred to this briefly when we talked about strings, but the first element of an array always is the 0 element. Float array 0, float array square brackets 0 would be the first element of this array, and float array square brackets 1 would be the second element. So of course number 5 would be the sixth element. Okay, let's move on. Loops are excellent for performing operations on all elements sequentially. Loops. Loops are excellent for this. You find arrays and loops used hand in hand all the time. You declare an array of something. You declare an array of 100 integers, or an array of 100 floats, or whatever. Now, you want to perform an operation on each one of those 100 elements. Are you going to write 100 lines of code, one for each element of the array? Do you really want to write 100 almost identical lines of code? Probably not. It's unlikely that you would. It could happen on a very rare occurrence where all the elements of the array are so different that there's no real way of making a common piece of code that could reference each one of them. But what typically happens is that you manipulate the elements of an array inside a loop. And the loop would typically be a for loop, essentially saying for some loop index equals 0 all the way up to the loop index of the number of elements, so incrementing by 1 each time, reference one element of the array and do something with it. Now remember, in that example that I just read out to you, the array element would start with 0 and go up to n-1 for an array of n elements, not going from 1 to n. That's simply the way that C works. It always goes 0 to n-1. If you've come from a language like BASIC or Pascal, then you'll find this difficult to get used to at first. It does take some time to adjust to it. But once we start having a look at pointers, and in particular pointer arithmetic, you'll find that the 0 to n-1 way of doing things actually makes a lot more sense than the 1 to n. It may not be more user-friendly from a programmer perspective, but it certainly reflects the system architecture and the actual memory architecture of any given computer system much more accurately than the 1 to n system does. Okay, that's pretty much it for the conceptual discussion on arrays. Let's now go and have a look at some actual coding, some samples. Okay, I've created this file here called array.c. This is in the chapter 6 folder. And what we're going to do is we're going to declare an array of, say, floats. We're going to read some floating point numbers into that array, and then we're going to print them out, or at least we're going to print out one of them. Let's have a go at that. Okay, so first we need the array itself. So we'll call this a float, and we'll call this, we can just call it array. That's a good enough name. It's actually fine to call something array. How many do we want? How about 5? Okay, excellent. Now, the next step is to actually read something in from the keyboard into each one of these. Now we could do it like this. We could do printf please enter element number 1, and then do a scanf. We might do an f flush first, and a scanf of a %f, and then the ampersand, don't forget the ampersand on, now ampersand of what? Well, element number 1. We want to read in element number 1. Now remember how to reference an individual element. We say the name of the array, then open brackets, and inside the square brackets we need to put the element number that we're referencing. So do we put number 1? Well, we don't. Actually, we put number 0, because we're trying to reference the first element. We always start with 0. Don't forget that. Okay, now that bit of code will actually work, but that will only work for the first one. So then what we'd have to do is we'd have to copy and paste all that code again, and then change this to a 2 and change this to a 1, and so on, and we'd have to do that 5 times. Okay, now obviously that's a little silly, so we won't do that. What we'll do instead is we'll put this in a loop. I'll just get rid of this code down here, and we'll use a for loop, and we'll use an array index called I for index. Then, so we'll initialize I. What's I going to start with? it's going to be the first one. We're going to start with the first one. Now the first one is always 0. This is very standard. I know that some of you might want to put a 1 there. Please get in the habit of putting a 0 there. It's very standard in C. Now we say we're going for I, we could write it like this, less than or equal to 4, because we have to go up 0, 1, 2, 3, 4. That's 5 elements, 0 to 4. But we typically don't write it that way. What we typically do is we typically do I is less than 5, and that way this number matches this number. It's always good to have them the same, because then you can really tell that we're not making any mistakes. So you say for I equals 0, I is less than 5. Notice that that will actually stop when it gets to 4. When it gets to 5 it will jump out of the loop, and then you say I equals I plus 1. And open brackets, and we're obviously going to do the close brackets here. Do our indentation. Okay. So please enter element number 1. Well, we don't want to ask them for element number 1 every single time. We don't want to have 5 questions that all say please enter element number 1. What we want to do instead is say please enter element number %d. And then we actually want to ask them for I. Is it I? Well, we have to make a decision here. Do we want it to say please enter element number 1, then 2, then 3, then 4, then 5, or do we ask them for elements 0, 1, 2, 3, 4? Well, let's pretend that the users of this program know nothing about the internal architecture of the system, and they might get a little bit confused if we ask them for element number 0. So we'll actually ask them for element number 1, which means we'll do this, I plus 1. Then we'll do our scanf, and what we'll actually do is we'll read in element I every time. This is perfectly okay to do. It is okay to put a variable number inside the square brackets. You may recall from our conceptual discussion about arrays that I said you must put an integer literal inside brackets. But that is only up here. You must put an integer literal inside the brackets when you're declaring arrays. You could do it like this, 5 plus 4 divided by 3. Well, actually 5, how about 5 plus 4 like that, divided by 3. Now that's obviously 9 divided by 3, which is 3. Now that was going to work fine. It obviously will not add up to 5, but it will still compile and still run. But we actually want 5 in this case. However, when you're using an array, it is perfectly okay to reference each element of the array by using an index that is a variable, not necessarily a literal. So that should work as well. Now, having read those in, well, let's see if we can actually read them in. Okay, let's try that. So we'll go up and compile. Oh, we've got some errors. Hang on. Let's check out what those errors are. I undeclared. Oh, okay, well we've actually forgotten to declare I. So that's always a good one. Int I, semicolon, try again. 0 errors this time. So we'll run it. About 1.2, 2.3, 3.4, 4.5, and 5.6. Well, the point was that it asked the question correctly. It asked 5 questions, and every single time it incremented the number that we're asking from 1 through to 5. So good. That bit's working. Now let's ask the user which element they'd like to print out. We could print out all the elements, but I'd just like to print out one, just to see how that goes. So we go down to here, and we ask them the question. Printf, which element do you want to see? And an F flush of stood in, and a scanf of, now we're going to be asking for an integer here. We're going to be asking like an element number 1, element 2, element 3. So we'll do that. And what are we going to read that into? Well, we need another variable, don't we? We need int index. We could have used I suppose. I mean, we finished with I up here. but I'm just going to keep them separate because it's less confusing for a training course such as this. So we need the address of index. So they're going to have typed in some number in the range 1 to 5. So now we print out the answer. Element %d is %f, because it's a float, don't forget. So element %d, so that's index, element 1, element 2, etc. And now we want to see the actual array element. So now, is that correct? Have I left something out here? I think I have. Let's say they said that they wanted to see element number 1. What would happen? Well, this number here would be 1. However, we're really trying to see array element 0, which is the first one, isn't it? They're asking for the first one. They're not necessarily asking for element number 1. They're asking for the first element. So we've actually got to subtract 1 there. And that's okay to do as well. Up here I said it's okay to put a variable inside square brackets. Here we're actually putting an integer expression inside square brackets, and that's okay as well. Which just raises a question in my head. Let's say we didn't put the -1 there and they said that they wanted to see element number 5. And so this value here would be 5. And this would be array number 5, or array index 5, which means this would be the 6th element of the array. Remember? Okay, so the 6th element, but we only have 5 elements. So they'd be asking to see an element that's actually not part of the array at all. What would happen? It's a good question. If you'd like to take a second, pause the video and have a think about what might happen. It'd be a good time to do that. Did you come up with an answer? Okay, the answer is, well, there's a few possibilities. One is the program could stop and output some kind of error message saying you've accessed a piece of an array that you're not allowed to, or it doesn't exist, or something like that. That would be one option. That doesn't happen. Another option would be the program might crash. That's not likely in this particular example, but it could happen in some examples. What's probably going to happen is that you're just going to get a random number. You're going to get the number, whatever float is sitting in memory immediately after our array of 5 floats. So if you can picture a little collection, a little sequence of 5 boxes in memory, and they all got numbers in them, and now next to them in memory is going to be something else. Off one end is going to be, it won't be necessarily another float, but there's going to be a piece of memory with a random number in there, and you can interpret it as a float if you want to. Whatever that number is, that's what's going to get output. Interesting. Believe me, it's true. Anyway, let's see if that works. Compile, no errors, run. Okay, we'll try again. 1.2, 2.3, 3.4, 4.5, 5.6. Which element do you want to see? Oh, I don't know. How about number 5? That's clearly wrong. So what have I done wrong here? Yep, you guessed it. I forgot to put the -1 back in. You're probably already sitting there going, hang on, he hasn't put the -1 back in. Okay, now I have. Let's try it again. Compile. Still no errors, but we did have an error, but it wasn't a compile error. 1.2, 2.3, 3.4, 4.5. I'd like to see element number 5, please. It's 5.60000. Okay, so that seems to be working. Excellent. So this bit of code that I've just written for you is a pretty good classic example of how to use arrays. We've got a loop here which performs an operation on each element of the array, and we're using the I inside square brackets there, which is very, very standard. You'll see that just about everywhere in the language of C. And then we manipulate a single element of the array by itself. We can even use a sophisticated arithmetic expression inside the square brackets if we need to. All of this is very standard, and to any experienced C programmer, it's not at all difficult. This is very simple stuff. Anyway, let's move on and see a bit more about arrays.